Hello, in today's video we're going to be talking about the idea of molecular weights. And you already know a little bit about atomic weights or atomic masses, and you know that those numbers can be found on the periodic table. So a quick review of that is every element on the periodic table has a weighted average that we call the weighted average of their isotope masses that we call the atomic mass. So let's take an example. Let's take carbon. We can look at the periodic table and we'll know that the atomic mass of carbon is 12.01 AMU. So that is the atomic mass for carbon, the element carbon. Now, since we've been learning how to name molecules and compounds and writing out their formulas, we're going to need to expand this idea from just a single element to many elements within a single compound. So that's where the idea of molecular comes from. So let's take a very common molecule. Let's take the carbon dioxide molecule, CO2. We want to find the molecular weight of this entire molecule. And the way we do that is we take the sum of the atomic masses for each element multiplied by the number of times that that element is present in the molecule. So how does that work? Let's say for carbon dioxide we have one carbon and two oxygens. So what we would do is we would write out an equation in such a way that we multiply the number of each element times its atomic mass and sum that over all the elements. So for carbon dioxide we have one carbon, and we're going to multiply it by its atomic mass, which is found on the periodic table, which we just said was 12.01 AMUs, 12.01 AMU. We're going to add to this to find the overall molecular weight of carbon dioxide. We're going to add to that the contribution from oxygen to the overall weight. So since there are two oxygens, we're going to add 2 times the atomic mass of oxygen, which is 16.00 AMU. Since there are only two elements inside of this carbon dioxide that make up their carbon dioxide, we will only have 2 parts to add together here. Now of course we have to take into account significant figures. So the periodic table that I have memorized in my head has 2 decimal places. So let's figure out what the overall molecular weight is with the correct sig fig for carbon dioxide. 1 times 12.01 is 12.01 AMU. We're going to add to that 2 times 16 AMU, which is 32.00 AMU. So each one of these has 2 decimal places. Our last step in calculating the atomic or the molecular weight of this molecule is to add them together. So we're going to be looking for a final answer that has 2 decimal places. So when you add 12.01 to 32.00, you get 44.01 AMU. That is our molecular weight for carbon dioxide. Now, AMUs aren't the most useful of units, and in the next coming up videos, I'll be changing that to something else. But for right now, this is the molecular weight according to AMUs. We can find the molecular weight for any molecule or any compound as long as we know the formula by taking the number of times each element within that compound shows up and multiplying it by that element's atomic mass. Then we sum over all of the different elements within the molecular compound, and we get the molecular weight of that molecular compound. So with that, I just want to say this is a quick introduction into the world of molecular weights. We're going to make this a little bit more advanced as we go on. But for right now, have a great night. I'll see you all in class tomorrow.